So welcome to the walkthrough for the Edexcel Higher paper. It's the summer of 2019 and it's the paper 2 Calc Aloud, so let's go. So to begin with, bog standard inequalities. First one, just treat it like an equal sign. So I would subtract 11n from both sides. And as you can see, works out quite nice. Divide both sides by 3 and you are done. Next one, a double inequality, but the rules of algebra still apply. Do the same to all sides, even if there's 3 sides. So take away 3 from every term. That goes down to -5. The middle goes to x, and the right side goes down to 1. The right-hand inequality is an equals to, and that's important because it means it needs a closed circle. So close that one up, and on -5, an open circle with a straight line joining them up. Nice 5-mark starter. Number 2, as you can see, I've cheated because me and technology, they're not good. Don't forget though, you could go 2 ways about this. I'll mention both. I went for the y equals mx plus c, which means realizing that the plus c, the y-intercept, is -3, as you can see there, and the gradient is +2. Be careful with that one because, as you can see, the scales for the x and y axes are actually different. So a gradient of 2 means for every 1 unit across you go, which in this case is 2 squares, you go up 2. So it's one of those weird situations where although the gradient is 2, it actually goes diagonally from corner to corner, but that's due to the scale. Or you could, if you prefer, go for the old table of values, pick a few, 2 or 3, depends on your preference, and sub them in. So y equals 2 zeros, take away 3, 2 1s, take away 3, 2 2s, take away 3, get them coordinates plotted, it'd be that one, and that one. So the same thing happens. All about personal preference. In terms of speed, I think the first one slightly nudges it, but there you go. Number 3, Hannah's doing a day trip. Great stuff. So 195 students, that's the first thing I pay attention to. Sample of 30, 10 out of the 30 say theme park. Of, out of means multiply by the population on your calc, 65. That's all it is. Stating any assumption. Now the exact wording I've done on my worked answers is that the sample has the same proportion as the population, or words to the effect that it is representative of the population, or anything along those lines. But as always, with these 1 markers, giving you 3 lines, don't fill those 3 lines. You're wasting your time, you're waffling. 1 line should say it all. Number 4. So don't forget, with centimetres cubed interchangeable with millilitres. 1 centimetre cubed is 1 millilitre, 1,000 is 1 litre, and so on. So first thing I do is multiply all the dimensions. 3420 centimetres cubed, in other words, millilitres. To be 2/3 full, you do 2/3 times that number, 3,420, and I'm getting 2,280. A cup holds 275 ml, so that means we need to divide to see how many cups we can fill. And no matter what answer we get, it's about being completely filled. So even if the answer was 0.9, it still gets rounded down. In this case, though, no need to worry about that. It was 8.2909, but rounded down if it's about how many are fully filled. Number 5, hope it's pretty obvious, it's right-angled. We're dealing with hypotenuse. We want the opposite. The adjacent is useless. So in terms of SOHCAHTOA, it's a SO. The opposite is what we're after. These are left next to each other. So to find x, we multiply the hypotenuse and the sine of the angle. It wants 2 decimal places. I get 9.85058, etc., etc. So obviously I'll leave it at 9.85. Number 6, be careful. All right, it looks like an errors, a bounds question. It looks like one of those where you go up and down by half. It's not. This one, I've actually written it on my work solutions. This one's actually called truncation. It's like having a receipt and it gets wet, so it chops off the numbers. If the digit that before the chopping off is a 5, it can never be a 4. That can never go down to a 4. So the smallest that 8.3 could have been is 8.30000, or just 8.3. Okay, we don't go down to 8.2s. It's not possible. The answer on her calculator display began. What could come after the 3, though? Well, it could be 8.3 and almost an infinite number of 9s. Okay, the mark scheme does accept 8.4, but me personally, I prefer the logic of 8.39 recurring. So as I say, that's truncation, comes under the topic of errors and bounds, but it's not quite the same thing. Number 7, good old wordy ratio. You know they're coming. My advice is always lay it out, organize your thoughts. They use consecutive letters for a reason, to remind you. The total is 360. The ratio A and B is 2 to 7. C and D get 1.5 times what Abby gets. Well, if Abby gets 2, they get 3 each then. And it won't, chances are it's not going to be those exact numbers, but the numbers would be in that proportion. Work out the amount that Ben gets. So we're only interested in Ben's 7 out of, add them up. Ben gets 7/15 of the share of times 360. Grab your calcs, 168. No need to work out the others. Number 8, a little standard form. So 8a, where does the decimal point need to be? After the 5. How many times have we multiplied it by 10? Well, it's moved 1, 2, 3 times, and to signify it's a small number, you need a minus power. Timesing by 10 cubed means you multiply it by 10 3 times. So the 1 becomes 14, becomes 145, becomes 1452. No zeros on the end. Number 9. One of those where it never feels like there's enough numbers. Don't forget, though, this all boils down to scale factors. If you double a square's length, you don't double its area. Its area is doubled. In other words, if you double a length, you double the height as well. The area is quadrupled, or in other words, It's the linear scale factor squared. So here, circumference is a length. So the linear scale factor is a multiplier of 0.9. But if you want the ratio of the area, you need to square that. 0.9 squared is 0.81, or in other words, 81%, or 81 over 100. Either way, it's entirely up to you. It wants the circumference of circle B, so circle B is smaller, so the second number should be smaller than the first. How can the second number be 81% of the first number? Well, if the first number is 100, 81% of 100 is 81. Keep it simple, don't overcomplicate. Similar bit of logic here. Square E. I did a little diagram. Draw square E. F is a little bit smaller. The area is 44% greater. So if the area here is 1, the area here is 1.44. That's 44% bigger. But just like I explained in part A, to go from linear scale factor to area scale factor, you square it. To go from area to linear, you square root it. So here, the side length would be 1 and 1. The side length here would be 1.2 and 1.2. In other words, the ratio, work out the ratio of E to F. E is the side, like so. It's the side, not the area. So you could say 1.2 to 1. And that's a perfectly acceptable answer. Mark Scheme says that's fine. I prefer whole numbers, so I'll times both sides by 5. That's my preference for a right answer. Number 10. Nice, easy, straightforward, no need to overthink. Probability trees. Splits should add up to 1, and the probabilities don't change. That's why it's a really nice question. Work out the probability that her train will be late on at least one of the 2 days. Well, that's late both. That's late Thursday. That's late Friday. So you've got a choice here. You could work out the probability of all 3 of those branches. That means do Thursday times Friday, Thursday times Friday, Thursday times Friday, add them all up. Not me though. I'll do 1 minus not late, not late. In other words, 1 minus on time twice. On time twice is 0.85 times by 0.85. Calculator will either say 111 over 400. If you've got a newer calc that loves its big fractions, I'll prefer a decimal though, 0.2775 for the right answer. On we go. So cumulative frequency, yes, I've cheated for part B, but you knew that was coming. Cumulative, don't forget, means add up as you go along. So first group contains 5, add on 30, add on 20, add on 15, add on the 8, add on the little 2, and make sure you get the same number up there. And when you go on to the next page to plot cumulative frequencies, please don't forget, for cumulative frequencies, you plot using upper class boundaries. Okay, so make sure you use those, as I have done. So plotting the upper class boundaries, join them up with a straight line, and there you go for part B. Now part C, I've underlined it in red. It does say percentage of office workers, not number of office workers, although you do need the number of office workers. So more than 90 minutes, there's 90. Go up to your line and along. As you can see, I have 3 squares above, each little square being 2 people. So the reading from my graph, and it does agree with the mark scheme, the perfect answer is 6 out of 80. That's the fraction of the office workers. You want to turn it into percentage. Times it by 100. 7.5%. Number 12. So area of a sector, but not as straightforward as find it, because it's already given you they've given you the area. Calculate the perimeter. So the key is, what on earth is the angle? So use the fact that you've been given the area of the sector, which is 40. There's a formula for the area of a sector. It's the area of a triangle, of a circle, pi multiplied by the radius squared, multiplied by how much of a circle do we have? Don't know. So it's x 360ths. Your job is muck around with it. So grab your calc, start with 40, multiply both sides by 360. What on earth was I writing for 7 squared? Sure you all spotted it, apologies. Multiply both sides by 360, divide both sides by 49, divide both sides by pi. I get the angle to be 93.54-ish. Now you can work on the perimeter. Don't forget though, the perimeter of a sector is not just the arc, it's the 2 7s as well. So perimeter is 7 plus 7. And the formula for the area, for the length of an arc is 2 pi r. That's the circumference of a circle, but we've got a fraction of a circle. We've got 93.54 360ths of a circle. And if you stick all that in your calc, I got 25.4285. They wanted 3 sig figs. It's 25.4. On to some algebra. So that's 6 plus at the beginning. Leave it for a bit. Let's focus on what's inside. So we've got x plus 5. Now, as you can see, I just move it near the top a bit. You can put it over 1 if it helps you. Divide means multiply by the reciprocal. And while you're there, factorize this quadratic. You can be rest assured one of the brackets will be x plus 5. But let's not assume. 2 numbers which multiply to make -10, add together to make +3. Well, it is indeed +5 and -2. So we can get rid of that. In other words, we can ignore the first part entirely, and we can cross out the x plus 5. Now we need to move on. How on earth are we going to take the x minus 1 over x minus 2 and add it to 6? Well, you can only add fractions if the denominators are the same. So for the 6, let's multiply it by x minus 2 over x minus 2. That's the key. Now that you've got them with the same denominator, you can just add the tops. So all over x minus 2. Expand, we've got 6x minus 12. There's a plus 1 here, so we can just ignore the brackets. There's a plus x and a minus 1. And we're there, we can just tidy up the top. Simplify. 6x plus x minus 12 minus 1. And it won't get any simpler than that. Number 14, my usual bit of cheating, the greens for part B. So ignore that for a sec, focus on the red. So on the red, I got a slightly different answer here to what I got on my work solutions. On my work solutions, I got 15 over 22.5. I've drawn a slightly different one here, but the mark scheme is quite lenient. So to estimate the gradient, draw on a good tangent. Good means large, don't do tiny triangles, and make sure you try and follow the general trend. Don't avoid crossing inside. I'd say my red triangle here is a pretty good one. It's also a good one because reading off the height of it is 15 is quite easy, and horizontally is not bad either. 5, 10, so 5, 10, 15, nearly 16. It's more like 14 or something, isn't it? 5, 10, sorry, no, 15, 2 squares short, so it's more like 18 across. So the gradient for mine will be 15 divided by 18, which is also 5/6. Woo! Which is one of our common 0.83 recurring. As I say, on what I've done on my worked answers, I got 0.67, but the mark scheme's pretty generous. It allows any answer from 0.6 up to 1 inclusive. And for part I, describe what that represents. Only needs one word, that's why they've only given you one line. It represents acceleration. Let me just explain what the green lines are, because some of you will probably know already. Part B says to you, work out an estimate for the distance travelled in the first 20 seconds with strips of equal width. So I've done this one in green. I'll change to green pen as well, so we keep it all in the family. So I've simply, on my worked answers, called the strips A, B, C, and D. Now, to work out the areas of each, B, C, and D are trapeziums. A is a triangle. The width of each one, equal width of each one is 5. You just need to read off the heights. So I got that first height to be 4, then 12, then 18, and then 20. Again, mark scheme allows a little bit either way, but now you can crack on with finding the areas. So I just simply did A, which was a triangle. It was a half. The base is 5. The height was 4. That gives me 10. B, we're now onto trapeziums. So you have to do a half. Now the parallel sides are added. I'll only do this for B. I won't waffle through and repeat for C and D. That's the height of 4 and the height of 12. So the C will have heights of 12 and 18 and so on. So it's 4 plus 12 added together times the width between them is always 5. I'll speed it up now. So C was a half of 12 plus 18, all times by 5. D was a half, and the two heights were 18 and 20, multiplied by 5 to get 95. So all in all, I got the answer of 220. Mark scheme allows anything from 215 to 225, again inclusive. Question 15, one of the trickier, changing the subject or transposition of formulas because you want m equals, but there's two m's, top and bottom, numerator and denominator. Well, first job, level it off. Get rid of the thing on the bottom. Multiply both sides by m minus 1. I'll expand it at the same time. You do what's called isolate your m's. Get your m's on one side. You could choose the left or the right. I usually choose the left, and I will again here. So subtract 3m from both sides, adding f to both sides. Now we've got the m's isolated, we can take an m out, leaving us with f minus 3. And basically, folks, we're there. The f plus 4 is the numerator, and we divide by the brackets, so the f minus 3 goes on the bottom. Now, if you isolated them to the right-hand side, you'll just get all the signs changing there. You'd get minus f minus 4, minus f plus 3. It's a little bit untidy, but you won't know that straight away. But it's still a correct answer. Number 16. So L is not quite how you want it. You want it y equals. That's how we like it, because then we know the gradient and the intercept if it's needed. So we know that the gradient of L is the coefficient of x. It's 4/3. Find an equation of the straight line that is perpendicular. So we've got the gradient and passes through A. So we've got the gradient, we've got the x coordinate, we've got the y coordinate. If we go for y equals mx plus c, we can find the c. So y equals the gradient. I've forgotten to flip it and change the sign, so it's negative 3/4. Sorry, I've forgotten to write down the gradient of the perpendicular is the negative reciprocal. Nearly caught myself out there. So it's gradient, which is m, multiplied by x, which is 3. Grab your calculator to find c. Start with 5, and you need to add 9/4. You should get minus 11/4, or the equivalent of, for your c, and that means you've got everything you need. Y equals mx plus c again, but the m is the perpendicular gradient, and the plus c is that on the end, negative 11/4. Number 17, wordy, probability, and a strange one. So, explain why the least possible number of cubes. So, on the top, it's out of 11. On the bottom, it's out of 8. So the number of cubes must be a multiple of 11 and a multiple of 8. So why is the least 88? Because the lowest common multiple of 11 and 8 is 88. So you could double it. I mean, it could be 176. It could be 8,800, but it asks for y is 88 the least, LCM. Now, B is a doozy if you don't spot the better way of doing it. So first of all, in fact, let's just scroll up a bit. Let's just make a little list. We've got small cubes and large cubes in the ratio of 4 to 7. We've got red and yellow cubes in the ratio of 3 to 5. But watch this. All the small cubes are yellow. Now you've got lots going on. I know some people, when this happened, they tried probability trees. It got into a right mess. Tough one, this, folks. Very tough. Best way of thinking about it, believe it or not, is a two-way table. Because it falls into the category of, you've got small and large, you've got red and white. It's like those questions where you've got boys, girls, taking German, taking French. You've got a Venn diagram's a possibility, but not here for me. Two-way table is your better option. So we can line up small and large and our total column, and we can put a row in for red and yellow. Now here's how you go about filling in. It wants the least possible of large yellow cubes. So that's going to be what number goes in there, is really what it's all about. So here's the information. First of all, lowest means we're actually using the answer to part A. There's 88. Now what we do know is that 3/5 are red. Sorry, 3/8 are red. My apologies. 5/8 are yellow. So in other words, calc if you need it, 33 are red, 55 are yellow. And then we look over here to small and large. Okay, so with our small and large, the key is there are none. All of the small cubes are yellow. So none of the small cubes there. So that has to be a 33. Okay, that's the first key. Next, when it comes to the fractions, 4/11 and 7/11 are small and large. 1/11 is 8, so 4/11 is 32. The rest are large, 56. And again, because that's 0, that's 32, but the only number we're really interested in, which we could have done by now, 56 minus 33 is 23. Without a two-way table, I think that's an extremely tricky question. So there we go, you live and learn. I hope that one's helped, but there's more questions to come, obviously. So number 18, you must give a reason, as I always do. I've written out my reasons in full on my work solution. So here I'll simply talk through them and I'll draw the values on as we go. So first of all, we've got an isosceles triangle with B at the vertex. The base angles of an isosceles, because there's a line of symmetry down here, the base angles will be equal and will make the triangle add up to 180. So they must be 70 each. Okay, then you've got the idea that because we know that's 70, the angle at C creates a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral add up to 180 degrees. Now we know that's 110, we have a second isosceles triangle. Here we have the base angles again. These must also be equal and make the triangle add up to 180. So they are each 35. Why does all this help? Because we wanted angle ADE. That angle there. And by working out the 70, by working out the 110, which told us the 35, we now finish off angles on a straight line add up to 180. So 180 minus 70, 110, take away 35, means angle ADE is 75 degrees. As I say, I've written that out in full, no shortcuts, on my worked solutions. Number 19, 3D trig boils down to basically SOHCAHTOA, Pythag SOHCAHTOA, but not an easy spot. So I've started myself off here. First thing is this ratio that they're trying to muck around with. D to M is 2, M to A is 3. In other words, A to M to A, whatever you want to call it, is 3/5 of the 15. I'll make it 9 then. So M to A is 9. Yeah, that's worth 6, but we don't need that. It's M to A that will come into play later. Next, though, I've highlighted this purple triangle. I want the height of it. I want the length of E to B. Reason why, as you can tell, it's the green triangle because it wants the size of the angle between EM and the base of the prism. So the examiner is wanting you to find that angle there. I'll call it X. The only way you can work out angle X is if you know two of the lines of that triangle. That's M to E, M to B, or E to B. Any two of them and you're cooking. So I'm going to get E to B. Reason being, they've given us a 35 nicely. They've given us a 15. They've given us a nice right-angled triangle. We can work out the opposite. It's a TOA. Opposite E to B is tan of 35 multiplied by the 15. It's 10.5-ish. 10.503. So now we need either M to E or M to B. It's M to B I go for. Now it doesn't look like it, but pretend you're looking down on a plan view. There's B up here, and A will actually have the right-angled triangle there. It just won't look like it on our perspective, and M is there. Now that 9 pays off, because 9 is M to A. 15 is A to B. So this line along here, yep, you've guessed it, it's Pythagoras. To get M to B, that's the hypotenuse. You need to do 15 squared plus 9 squared, square root your answer. My calc says 3 root 34, or the decimal equivalent of. Now I can actually work on finding X. Let's draw our third triangle. We've got the opposite side E to B. That's what we found on the first stage, first step. We've also got M to B. That's what we've just found. And we're wanting this angle here. So again, it's TOA, because we've got there's the right angle. It's the opposite and it's the adjacent. So we've got to inverse tan, because when you want an angle, you have to shift tan it or second function tan it, depends on the calc. but as long as it's opposite divided by adjacent, you'll be there. Now it wants one decimal place. I get 30.981, in other words, 31.0 degrees for a belter of a 3D trig question. Number 20. And finally, a belter of a vectors question. First thing to note is all the info we're given. C to D is A. I'm a big fan of getting it on the diagram. D to E is B. We'll do it there. F to C is A minus B. Looks weird, but I'll stick it on. So it wants, first of all, F to E. So we need to go from there to there, the long way around. So it'll be A and another A. It'll be minus B plus a B. There you go. So that's the easy part. Now comes the killer final part. It tells you M is the midpoint. So whenever you've got a midpoint or any ratio, I like to stick fractions on. Next thing, I'm also going to start thinking about how I get around other parts of my triangle, of my trapezium. But I'll do that in a sec. X is the point such that F to X and X to M, I don't like these, would like a number, but it doesn't mean you can't write it as a fraction. A fraction is, so this is the longer bit, that's N, divided by N plus 1. This little bit here will be this part, the 1. And it will be 1 over N plus 1. And that's them split into fractions. So, next bit, now I've already done this, so I know it takes up a lot of room, so I'm going to pinch a bit of room up here. Let's first of all consider how we get from C to E. Because C to E, it tells you CXE is a straight line. That's not in question. It tells you. So whatever C to E is, X has to be on that line. So we need C to E. And it's nice, it's just A plus B. But here's the logic, here's the key to this question. To go from C, let's just change colours, going to get a bit complicated. Let's go for a bit of orange. To go from C to E, notice how the A's and the B's are in proportion. There's one A, there's one B. So to go from C to X, that must also be the case. However many A's you have, you must have the same amount of B's. Okay, hope that makes sense. In order to lie on a straight line, C to E, the coefficients of A and B must be equal. Let's go back to a different colour. Let's move on. So now let's look at how on earth we get from F to M. Because we're going to need F to X or X to M. So we haven't even thought about this line yet. Let's do F to M. We need to go the long way. It's A minus B. We go to C first. A minus B. We go C to D, which is A. And we go D to M, which is a half of B. Let's tidy it up. 2A minus a half B. That's the key. That now helps us consider the journey from C 2x. To go from C to X, I'm going to go to F first. That means minus A minus B. So I'm now at F. I now need to get to X. In order to get to X, I need a multiple of this. And that multiple is that fraction there of there. Now, where the heck do we go? You could expand brackets, but I don't want to overcomplicate. So based on what I said a bit ago, the coefficients of A, in other words, the things in front of A, must be the same as the things in front of B. So although you could expand brackets, I wouldn't bother. Let's just look at what is in front of the A's. So here we've got a -1, and here we've got a 2 and this fraction. So let's just do 2 multiplied by it. And that's what would be in front of the A's if we expanded the brackets. What would be in front of the B's? Well, again, here we've got a 1. Say again. What do I mean? And here we've got minus, and we'd have a half times this. So it'd be 1 times n on the top and 2 times n plus 1 on the bottom. Let's level everything out. Let's multiply all 4 terms by 2 brackets n plus 1. So 2 brackets n plus 1 times -1. And I've expanded it. The n plus 1's cancel for the second term, so we just double the top. 1 times this, just this then, but I'll expand. And if you multiply by, they just disappear. Let's do a little bit of tidying up. -2n plus 4n. 2n minus n. And so we add 2 to both sides. We take away n from 1n from both sides. Wow. Worked out really easy at the end. Gotta be honest, out of doing all these past papers, I think that's the trickiest vectors question I've done yet so far. Really big one. Can tell from how long this video's taken. This looks like quite a tricky paper. But anyway, I hope that's helped. And let's hope paper 3 is a little bit easier.